Hello people, welcome to Gurukula. I'm Jay. So in the previous videos we are discussing about the concept that is multiple axis technique, and we might have seen what is frequency division multiple axis, and we also have seen what is time division multiple axis. So today in this particular video we are going to discuss about the topic code division multiple axis. So we will see what code division multiple axis is and the principle behind code division multiple axis and how is it differentiated from the other two techniques, that is FDMA and then CDMA. So now let's get into the topic. So as far as frequency division multiple axis is concerned, so every user will be differentiated with respect to a particular frequency range, and as it is depicted in the figure, each and every user will be allotted a different frequency band, and then each and every frequency bands will have a gap, and that is what we call it as guard bands, and these guard bands are introduced to avoid any interference between the uses. So as you could see over in the diagram over here, the official representation of FDMA, and the uses are restricted or the uses are differentiated in terms of frequency. So this principle is what we have discussed as frequency division multiple axis. So whereas time division multiple axis is concerned, the difference is instead of allocating different frequency bands for different uses, the entire range of spectrum is allocated for each and every user, but the differentiation is done in terms of time period, meaning each and every user will be allocated the entire range of frequencies for only a particular time period. So as depicted in the figure, you could see that the users are differentiated with respect to time slots. So whenever the user is getting his particular time slot, he could be able to communicate the messages for the entire spectrum by utilizing the entire spectrum, so that literally any user will not have any restrictions on the band of frequencies he can use. He can use the entire frequency band, but the restriction is imposed on the time period. He can use the entire frequency band only for a particular period of time, so that each and every user will have their own chances or their own time slots to communicate their messages, which will be added with some preamble and then trailer bits, and these TDMA formats will be passed on to the next user once the user one have been communicated, finished his communication. So whenever the user gets a chance, he can able to communicate the messages, but the users are restricted only in terms of the time period. So that is the principle behind time division multiple axis. But there are certain drawbacks with the FDMA and then the CDMA technique. As far as FDMA is concerned, the users are restricted or users are limited to particular frequency band, which means they could able to send on the signals that is suited within that particular frequency band. If a user wants an higher bandwidth, or if he wants to communicate a very larger bandwidth of signals, he could not able to do that with respect to FDMA. And whereas this problem have been overcome in TDMA technique, because there is no literally restrictions on the frequency band. He can use a wideband signal, so entire frequency spectrum can be utilized by one single user at a time. But the problem comes, he can use the entire frequency spectrum only for a particular period of time. So this kind of multiple access cannot be used for continuous transmission applications. So if at all a user has to communicate continuously and for a larger bandwidth, the TDMA will also get failed. So in order to address these problems, we should come up with a particular technology where there should not be any restrictions on the frequency band and as well as the time space, but still the user has to be separated so that they can access the spectrum simultaneously. So such kind of special multiple access technique is what we call it as code division multiple access. So here in code division multiple axis, as you could see, each and every mobile stations are allocated a different code. So this code actually differentiates the mobile uses. So each and every user on a network connected to a particular base station will be separated by a special code. So since it is separated by a code, we call this as code division multiple axis. So when you look at the official diagram over on the right hand side, you can see that the various uses are differentiated with respect to code, so that the uses are not restricted with respect to frequency, meaning that he can use the entire frequency spectrum that is available, and also he is not restricted on the time period, so that he can use the entire frequency for the entire time period. And then so each and every user will be allocated or differentiated with a code, so simultaneous transmission by all the users is possible. So that is the key advantage of CDMA technique when compared to FDMA and then TDMA technique. So this basic principle is what we call it as code division multiple access, where each and every user is separated with a code instead of time and frequency. So this is a basic working principle of an CDMA, where this particular diagram will help us to understand what actually happens in CDMA transmission. So let us consider that this is the transmitter side, there are two users. Let us take A and B. So A will be generating the messages, which will be a narrowband signals, which is represented green in color, and then B will also generate their own messages, which will also be another narrowband signal, that is represented in blue in color. So what will happen is, before transmission, all these signals will be multiplied with an unique code. We call that as PN sequence code. So, and these codes, when this narrowband signal is getting multiplied with this PN sequence code, and these narrowband signals will be converted to a wideband signal as depicted in the figure over here. And similarly, the same process will be applied for n number of users they are in the system. As you could notice that the code A is different from code B. So each and every users will be differentiated with a code. That is the basic principle behind CDMAs. So when the codes are getting multiplied with the narrowband signals generated by the user, the narrowband signals will be converted to wideband signals, and all these wideband signals will be transferred over a radio spectrum, that is my channel. So this is how each and every user signal will be sent over a channel, and that can be replicated over here. As you could see that each and every user will use an wideband signals over here. And at the receiver side, if at all I wanted to decrypt only the signals of user A, then I should use the same code whatever I have used at the transmitter side. So you can observe that at the transmitter side, the green color code, that is the code A, have been used to convert or to multiply the signals generated by the A. The same code has to be used at the receiver side as well. Doing so will again convert back the wideband signals to narrowband signals, and all other remaining wideband signal remains as such, so that only this particular frequency can be extracted back and it can be processed to further data replication processes. So this is the working principle of an code division multiple access. So this diagram actually shows you a basic illustration of code division multiple access. So the first waveform, this is nothing but the data signal whatever been generated by a particular user, and as you could see that this is an narrowband signal, and then all these narrowband signals will be multiplied with an pseudo random code, that is my PN sequence code, and when I multiply these two signals, I will end up with a signal something like this, and it is clearly noted that these signals are the wideband signals, and this signals is what actually we call it as encoded signals, and these encoded signals are only transmitted over the radio channel. So that is a basic illustration of code division multiple access. To sum up, the code division multiple access systems, the narrowband messages whatever been generated by the users are multiplied with a large band signal, and we call that as spreading signals. So actually the signals are getting spreaded, and the narrowband signals are converted to wideband signals. So the key principle is what we call it as signal spreading, and this spreading signals are nothing but the PN sequences whose chip rate is larger than the data rate of the messages. And then the code division multiple access uses the same carrier frequency to modulate all the users, and also it allows all the users to transmit simultaneously. And we also know that from the formal representation of CDMA diagram, we have seen that there is no restriction for the users on frequency part and as well as the time part. Since each and every users are differentiated with the code, all the users are allowed to transmit their messages simultaneously over the common radio spectrum. And then it is important to note that the CDMA uses the same carrier frequency to modulate all the uses. So this point will be stressed again when we are discussing the topic OFDMA. So there the difference will be coming when what will be the difference for using the same carrier frequency and different carrier frequency. So as of now, it is just requested to note down that the CDMA uses the same carrier frequency to modulate all the uses. So the first part of this point should be kept as a reminder, and this will be recalled back, and we will be revisiting this particular point when we discuss orthogonal frequency division multiple access, which is our maybe we will be seeing in the next videos. And then so each user has their own pseudo-random code word, so which is approximately orthogonal to all other code words. It is mandatory to have all the codes that we use in our systems are orthogonal to each other. So the meaning for orthogonal, it can be defined in multiple ways. In general, everyone will say the 90-degree phase shift is what we call it as orthogonal, but in general orthogonality can be stated as any minimum deviation that is required in order to differentiate two different signals without any interference is what we call it as orthogonality. Or from the physics, take for an example, there are two codes, and when you take a dot product of these two codes, that should result you in 0. So if this condition is getting satisfied, we can call that as the codes are orthogonality. So this principle is what we call it as orthogonal, and however orthogonality principle will be revisited again when we are discussing OFDMA. But as of now, we should understand that orthogonality is a principle which should be maintained between the codes, that meaning that user A and user B will have two different codes, and these two codes should be orthogonal to each other. So bringing orthogonality among the codes will make the signals of user A and user B to be very much uncorrelated. So bringing in the uncorrelation among the signals is an important parameter to reduce the interference in the transmission system. If at all the signal seems to be very much correlated, then that gives you the meaning that the signals are very similar to each other, then that will lead to intersymbol interference. So actually, so bringing in orthogonality among the codes is very important parameter, and it is mandatory to have the orthogonal codes in the system. So code A and code B should be orthogonal to each other, and however no matter how many number of codes we are using, we should have an orthogonality among the codes that we use for transmission and receiving purposes. So the receiver performs the time correlation function so that all other signals appears uncorrelated. However, the receiver should know the code word to decrypt the message signals. So that is actually known to us while discussing the working principle of code division multiple access. When we can actually decrypt the messages effectively only if the receiver knows the code word that is used for encrypting the messages at the transmitter side. In CDMA systems, the power of the user determines the noise floor of the entire system. So failing to incorporate the proper power control leads to near fault problem. So this is a very serious issue which has to be addressed in the CDMA technique, whereas we could say that this is the drawback which the code division multiple access faces. However, the code division multiple access overcomes the drawbacks that we faced in previous techniques such as FDMA and TDMA. There are certain drawbacks with the code division multiple access as well. One among those drawbacks are this near fault problem, which can be controlled by using a proper power control mechanism. So that is, say for an example, if the user with low power will not get a chance to connect to the base station, thereby these users will be left unserved, and this particular scenario is what we mean to as near fault problem. So we will try to go in detail about this near fault problem in the next slide, where it will be depicted with the figure. So actually there are certain pros and cons when compare for the CDMA technique. Unlike CDMA and FDMA, unlike TDMA and FDMA, CDMA has a soft limit on the capacity of the number of users. Actually, you do not have any hard limit on the number of users that you can incorporate into the system. So increasing the number of users in the system will lead to increased power. The only thing is the entire system power will go high, and simultaneously if you are not putting any limit on the number of users, then that will eventually degrade the performance of the entire system. So that will affect the quality of service of the entire system. So that theoretically there is no limit on adding the number of users. Only this much number of users should be there on the system. There is no limit theoretically, but in practical situations is concerned, when the number of users are getting increased, then the orthogonality among the codes cannot be maintained. If the orthogonality among the codes cannot be maintained, then that will actually leads to interference among the system, and this interference will degrade the quality of the system. So the multipath fading is considerably reduced as the signal spreads over the large bandwidth. So as you are, it is known that the FDMA and TDMA techniques are more prone to the noises contributed by the multipath fading, and your CDMA effectively combats the effects of multipath fading, since the signal spreads over a large bandwidth. And the channel data rates are very high because all the users are not restricted on time and as well as frequency. So each and every user will have access to the complete frequency ranges, and then simultaneous transmission of all the users is also possible. So that actually gives rise to achieve very high data rates in the CDMA system. And the symbol period is very less than the channel delay spread. Hence any delay signal for the duration more than one chip rate is considered as a noise. So any signal that is spreaded over a particular region, we consider that as a noise. And in order to receive these signals of CDMA system effectively, an ideal receiver cannot be effectively used in receiving the signal. So we will be using a special type of receivers, and we call that as R.M.K receivers. So R.M.K receivers is also there to discuss in detail, but not in this module. We will be discussing that in the fourth module. So as of now, you just understand that the R.M.K receivers are effectively used to receive the signals which are actually received the signal that are delayed in time. So R.M.K receivers are effective in receiving the signals which are which have different time periods. Self-jamming is a problem in CDMA which arises when the PN sequence are not orthogonal. So as it is already discussed, the orthogonality among the signals has to be maintained. If it is not maintained properly, then that will lead to interference between the uses. And the final last and drawback is the near-far problem, which will arise when the power levels of undesired user are higher. So now it's time to discuss what near-far problem is actually, and when does the near-far problem actually arises. We will see in the next slide. So let us consider that this is a near-far problem illustration. So when you observe this particular figure, we could see that this is the base station which is serving a geographical area that is marked like a circle over here, and you can observe that we have two mobile stations, MS1 and then MS2, and it is observed that MS1 is very closer to the base station and MS2 is farther to the base station. So let us consider that now my MS2 is the desired user which I wanted to serve now. So when I look into the received signal strength graph, so where I will take distance on the x-axis and the received signal strength on the y-axis, so this actually the signal strength that is depicted for MS1, that is your mobile station 1, and we know that from the basics of the wireless propagation models, when the distance between the base station and then the mobile station is increased, then there will be an degradation in the received signal strength. So that is what is depicted over here, and as of our example is concerned, MS1 is very closer to the base station, so that it will have higher power when as compared to the mobile station 2. So mobile station is very farther from the base station, so that at this particular distance the received signal strength will be very much lesser as compared to your mobile station 1. So this problem actually leads, since the MS2 is not having proper power levels to, or the signal strength to reach with the base station, this MS2 can be left unserved. So this problem is what we call it as near for problem. So in order to overcome this near for problem, the only way that we use is this mobile station 2 should transmit with an higher power in order to compensate this particular distance. So if we use higher power, then that will actually degrade the battery performance and more power consumption. So this is an cyclic process, and these are all the effects of near for problem. So we could see that there are three drawbacks which could arise because of this near for problem. The first one is channel capacity. So as per the Shannon's theorem, signal to noise ratio and channel capacity are directly proportional to each other. So lower the signal to noise ratio, lower the capacity is. So we have to try to keep the signal to noise ratio at an optimal level. And service degradation. So service quality will degrade due to the low signal to noise ratio due to high interference caused by user equipments. UE stands for user equipments at the cell edge transmitting at higher power in order to maintain the good SNR. So this is what actually we have discussed. So in order to maintain a good SNR, signal to noise ratio, this MS2 is forced to use high power levels to transmit their signals between the mobile station and then the base station, and this is what actually leads to service degradation. So since this is using high power, then there will be a battery drain. So each and mobile devices are powered with an battery pack that we hold in our hands. So that is powered by a battery pack. Your battery life will be affected when the user is far away from the base stations. So it is quite natural that it is already known that when the signal levels or the received signal strength are very less, our battery will drain as fast as possible because it is transmitting the signals with high power. So that requires higher energy that will consume more power from the battery. So these are all the major problems that is arise because of the near for problem. So this drawbacks has to be addressed effectively while designing the code division multiple access system. So then to talk about the capacity of code division multiple access, we said that there is no hard limit on the number of users that can be incorporated into a CDMA system. However, we cannot include infinite number of users in a restricted code division multiple access system, since it degrades the performance of the entire system. Actually the performance will be degraded for each and every user present inside the system. So it is always better to have a limit, an appreciable limit or acceptable limit, where the number of users that can access the system at the same time is given by the equation which is shown over here, and where W by R represents the processing gain, and where eta represents the thermal noise that is present in the background environments, and S is nothing but the power that is generated by each and every user, and N represents the total number of uses. So we have to satisfy this particular equation so as to decide what will be the total number of users that can be effectively allowed to access the code division multiple access system. So this is all about the code division multiple access system. So now when we try to compare the techniques whatever we have seen, that is frequency division multiple access, time division multiple access, and code division multiple access. In FDMA system, each and every user will be allocated a different frequency band, and then so users are not restricted on time. They can use the smaller frequency bands whatever been allocated to them for the continuous period of time. The drawback with FDMA is a user could not able to send or receive the signals in a larger bandwidth. If he has any signal that has to be transmitted with a larger bandwidth, that is not possible with FDMA systems. But continuous transmission is possible with FDMA systems. And secondly, we have seen TDMA, that is time division multiple access, where there is literally no restrictions on the frequency band, but entire frequency band will be accessed by a particular user, but only for a particular period of time. So continuous transmission is not possible in case of TDMA systems, but the advantage is he can use the entire frequency band, so that any level of bandwidth, if even the user has higher bandwidth of signals to transmit, he could able to transmit in the time division multiple access system. So finally today we have seen code division multiple access, where user doesn't have any restrictions on the frequency and as well as time, so which will help us to achieve higher data rates, but the users are differentiated with respect to code. So each and every user will be allocated a different codes, and it is understood that all the codes are to be maintained at orthogonal. So even though there is theoretically no hard limit on the number of users which can be incorporated in the system, but still in order to maintain the orthogonality among the codes, there should be a proper limit on the code division multiple axis in order to maintain the orthogonality. So bringing in the orthogonality will only make the signals to be uncorrelated, and that will reduce the interference in the system. So the main drawbacks of CDMA system which has to be addressed is the power control in order to overcome the near far problem. Other than that, we can achieve higher data rates in CDMA systems as compared to FDMA and then TDMA systems. So this is a very basic comparison of all the multiple axis techniques. So that is all about in this particular video. So just to sum up, we have started our discussion with the recap of the frequency division multiple axis and time division multiple axis, and later on we just started discussing on working of CDMA systems, where the diagram clearly explained how does a CDMA system will work, and then we have discussed certain pros and cons of CDMA systems and the capacity of CDMA system, which the equation, the n equation what we have shown actually decides the effective number of users can be allowed to simultaneously access the channel. And finally, we have seen the comparison between FDMA, TDMA and then CDMA system with respect to their principle. So that is all about today's video. So see you in the next video. Until then, happy learning.